Quantum physics tells us that there's no such thing as empty space.
Mysteriously, empty space isn't empty at all. It is constantly generating pairs of particles out of nothing.
These particle pairs, since they were created together, know about each other.
They appear everywhere, all the time, even in the room where you're sitting right now. But they exist for only an incredibly tiny fraction of a second before disappearing again, almost as quickly as they appeared.
They know about each other in a quantum entanglement sort of way.
Okay.
Well, if they know about each other because they're quantum entangled, and quantum entanglement means if something happens to one particle over here, the other one knows about it instantly. And the only way we can think about that is if there's some kind of wormhole between the two of them where it doesn't have to then travel through the physicality of space. Some kind of wormhole, because then you can get to two places instantly without, quote, violating the speed of light rule.
But what if those wormholes aren't just a theoretical shortcut through space? Some physicists have proposed an even more astonishing idea. They suggest that the very fabric of space-time itself may be woven from an enormous network of microscopic wormholes created by the restless sea of virtual particles. In other words, those tiny wormholes may actually weave together the fabric of our universe. Although we cannot measure these virtual particles directly, scientists know they are real because their effects can be measured. They subtly alter the behavior of real particles, producing tiny shifts in the energy levels of atoms, an effect known as the Lamb shift. They are also predicted to play an important role in Hawking radiation, a process through which black holes can slowly lose energy over immense periods of time. If empty space can produce particles, what is empty space actually made of? To answer that, we first need to understand that space is filled with invisible quantum fields. According to quantum field theory, every fundamental particle is associated with its own field. There is an electron field, a photon field, and many others. The particles we observe are actually excitations of these fields. For example, an excitation of the electron field appears as an electron, while an excitation of the photon field appears as a photon. You can think of these excitations as ripples on the surface of a calm ocean. But the story doesn't end there. Even in their lowest energy state, quantum fields are never completely still. They constantly ripple with tiny fluctuations. For an incredibly brief moment, those fluctuations can appear as pairs of particles and antiparticles before vanishing again. These are what physicists call virtual particles. But the mystery of empty space doesn't end there. On the largest scales imaginable, empty space reveals another astonishing secret. Our universe is made of about 68% invisible, mysterious energy called dark energy. One leading idea is that this dark energy is Einstein's cosmological constant, an intrinsic energy of empty space itself. Scientists have discovered that the universe is expanding at an accelerating rate, and dark energy is the leading explanation for this astonishing phenomenon. What we once thought was empty nothingness turns out to be one of the most active places in the universe. Empty space is anything but empty. It is a restless sea of quantum fields, constantly fluctuating and giving rise to phenomena that shape the universe itself.